Welcome in, guys. Welcome. And welcome everybody on Twitch. Right, so I've been doing some work on the book because I'm on holiday now. So I've spent a bit of time on it. And I've incorporated Derek's original chapters in the book. So I have rejigged them and add a bit more spiel to it. Oh, me and all these terms, you can tell I've been writing the book. So for example, got his data transfer in. So it's the original data transfer. Slightly tweaked it, but I've also made it now look the same as the rest of the book. So as you can see, look, lots of simulator in there. Hopefully the instructions are a lot easier to read than when it was C64 Debugger. And I've also done the math section. I can't say arithmetic. Yeah, math section.
You just did.
Say again.
You just did.
I just did.
What's cooking, Doc?
Oh, a Twitch clip without me in it. It was the BKD one. Anyway, so what I've done is I've taken.
Fairlane is here.
That is such a good intro. That is. Hey Fairlane, welcome. So I've added the maths bit, the arithmetic section from Derek's book, and I've tweaked it. I've put some graphics that I hope explain better. I won't say better because that's unfair to Derek, because it just quickly knocked the graphics together. But hopefully they will be explanatory in a self manner. Plus, as well as the text that goes with it. So we've done add. There's subtract. There is, and then we go on to the logic shifting. Yeah, the logic shifting. So I've put in graphics that are in keeping with what I'm trying to do within the book, the theme with the book. So hopefully these will now start explaining. What gets me right is, why didn't they call arithmetic shift left logically shift left? Then it could be LSL. Yeah. Why is it ASL? You know.
I've often thought the same.
Yeah,
it's just wrong. You should have LSL and LSR.
Yeah,
or
it's just,
ASL
it's
and
just
ASR.
wrong. Yeah,
one or the other, not both.
It's just wrong. I think whoever was designing the chip left, and somebody else come aboard and had a different idea. Hey, good, Mr. Dad, welcome.
Is it just the fact that when you arithmetic shift left, it adds the carry in?
No.
But logical shift right doesn't?
No, ASL doesn't give the carry in.
No. There's the two logical shifts on the screen, look. What's it telling you in the picture?
Well, don't ask me questions like that. I can't read that tonight. I'm not good at the minute with my eyes.
No, you add a 0 in, and whatever's kicked out the other end goes into the carry, yeah? The carry doesn't go in. The carry goes in on the rotate. On the rotate ones. Yeah, rotate left and rotate to the right. So, but they're the pictures that are on the screen, right? So I've like I say, I've added Derek's original chapters, but I've rejigged it a little bit to put them in. Then I've gone into binary code decimal, and then we go into doing the example. So we've got the users. The way I've done it, right? If we go back to the table of contents, right, we've got the assembly overview, and the overview chapters are there for them to walk through, yeah. And then we've got a chapter on basic programming techniques. Hey, TwitchIgor, welcome. And then we've got the problem, which is not the problem anymore. I have called it something else. Hang on. There we go. The workshop. Get in there. So we're going to be putting everything that we've read into practice. That's how I've done it. So the instruction set reference comes after it, but before it there is some walkthroughs of all the different areas in a basic sense. Yeah. So like the Boolean logic, I've tried to show how the and gates, or gates work, yeah. Based on what Derek had put in the chapter, yeah. But I've tried to make it a little bit in keeping with what I've got, yeah. So there's a section on how to set bits and stuff like that, bit transformation. I'm just wondering if that bit transformation needs to start on a new page. Hang on. Yeah, we'll sort that out. But yeah, so I've got where it's showing you what bits are going to be sorted out, and then we've got the walkthrough again, another walkthrough that they can walk through. Yeah. So that's how far I've got with the book. Now, the stream is basically going to be doing this, right? But I've got an issue. I don't know whether to change the simulator to run a program instead of a step by step, and then put breakpoints in. I don't know. We'll find out. So the problem, the workshop that's in the book is going to be how to solve this maze. So we're starting on the red and we need to get to the green. All right. So, and we're going to walk through how to do it. So I've gone and said that we are going to be using a flowchart to describe at a high level. So I've had to explain the three symbols that I use in the flowchart so they understand. And then there's the flowchart that's going to, so this is the process that we're going to go through to solve that maze. And I thought, why not stream trying to code it? But I think there's going to be other issues. So this is as far as I've got, where we are initializing the variables, and then as you can see, blank page. Because we ain't finished it. We've only done initialize variables, and it's 2, 3, 4 pages, 5 pages long. It's gonna be, this book is going to be huge. So we are currently running at 134 pages. Currently. Yeah. Currently 134 pages. So I've got the simulator code open just in case we need to do any bug fixing, because I bet you will find some. But this is the solver, yeah, the problem solver, yeah. So
okay, so that you learn them.
Phase 101.
You can learn them if you want, but you
hey
are
Phase,
not,
welcome. Welcome. Right, so this is the code. This is what I've got started. So what I was thinking of doing was streaming, coding the rest of it up. Then I can do the write-up against it. Yeah. So, right. So let me show you what I've got with the problem. Yeah. So this is the problem, and we're going to run the simulator. So here's the simulator. So I'm going to take a screen grab of this because I'm going to write all over it. Right. So there we go. Right. So as you can see, I've put my name on it because I didn't have my name on it. So now I've got my name on it. That was the first thing. And the maze in its basic form. So that template is what we're going to give the user. That template is what we're going to give the user that's reading the book. So basically what it is, look. Basically what it is we're just setting up some constants. We're telling it where the jump point, the start point is, which is here. We've set up the matrix. So this is the matrix array. Set that up. And that's it. That's all there is. Now the reason I've took a screenshot of it because I want to show you where the matrix is. So the matrix array is going to be here. Alright. Alright, let me see if I can do a pretty decent square with just a mouse. There we go. That is the array where the matrix data is. And the reason I've done it in memory like that is so when they're running it through the simulator, they can see. So there's going to be a little routine in there that works out which position in the array we need to look at, which is great because that will show them how to do multiplying and stuff like that. And also it will. I'm trying to make sure that we use as many of the instructions as possible, as many as we can get away with. We may not use all the addressing modes, but that's by the by. But as many of the instructions as we can get away with, and the route should be from here across here, up here, down there to there. Now there are a couple of dead ends. There is one here. So this is a dead end there, and there's also a dead end there. So there's two dead ends they're going to have to avoid, which is the same as in the book. You know what? One dead end there and one dead end there. In fact, let's go back in here. It actually does that. It turns a corner. There you go. So that is the workshop that we're going to try and get the person that's reading the book to build themselves, or we walk them through it. Yeah. So, any questions? Right, off you go then. Get coding now. So what we're going to do is we're going to follow our flowchart, and we're going to try and code each stage in its own right. So this is the initialization of the variables process. So if I go to the book and go back to the flowchart, so if I blow this up, that is this step here. So we've written this is the first step. So now we've got to determine available directions. Right. so that's the next section. So determine a variable directions. So here we're going to introduce them into bit masking, and the reason for that is because the I might as well do it here. Maze cell byte data structure. Right, so we've got 1, 2, 3, 4, 1, 2, 3, 4. So for each maze cell, it's a byte, right? And we are going to explain what all these are for. I've done a picture, but I might as well put it in the code as well. So, do that. No. Oh, why ain't there a right angle? No. I thought there was a right angle. Hang on. Right, what font am I using? Anybody know what font I'm using? Editor font. Consoles. Right, let's see what is in that. Consoles. Can't see. There we go. Have we got any right angles? Yes, we have. Here we go. That fella will do. Copy. There we go. Hey, there we go. Right. Cold hands. Oh, thank you for suggesting that. Right. So we are going to, let's put them all in. That and that. Oh, is there a... Or am I just being picky? Am I just being picky? John, you're being picky. Shut up. You're being picky, mate. Shut up. Right, let's do them all. Oops, no. That's that one, isn't it? And it's that. And it's that. And it's that. Right. Right, let's just make sure I've got the right number of dashes, which I haven't. There we go. Right, so I've got a picture of this. I got a picture of this somewhere. So we'll put it in the code so the users can see it as well. Right, where is it? Talk amongst yourselves. Illustrations. Right. Where is it? Data. That's the one. There we go. Right. That's what I've got to put into the code. So let me just copy that. So these bits are going to reflect something. So this is going to reflect that going west, south, east, north. And then we've got solution path. So that's the path, and this is going to signify a wall. Whoops. Right. So let me just try and explain this, right? This here is the direction to backtrack. So that's the direction we need to backtrack. Yeah. So if we go down a route, we need a way of going back. We need a way to know where we're going back. Yeah. Because we could have took a corner and gone down a thing and then backtracked, and we got to the corner, but we've already been down that way. We don't want to go back that way again. So that's the direction to backtrack. And these are to just basically to show what the solution is for the maze, and that determines a wall. Now, if you noticed, the data's got 80 already defined. That's because I've already predefined the wall, which is 80 in hex. So we already know that there's a wall there. Yeah. Right. So that is the data structure for each maze cell. Right. That's the data structure, and that's what we're going to try and keep to. I say try, because we do have two bits that are available that we can use. You know, just saying that we can use. Just saying. So that's the data structure. So let's do the next process on the flowchart, which is determine the available directions. Now, what we're going to do is at our location, we're going to look in all the directions to find out if we can go that way, yeah? And then we're going to add it to a small array called available doors, yeah? And that allows us to store how many possible exits there are, yeah? So, and I think I've got it right. So here we go. So first things first, we need to code. This is where I'm going to talk to him in the book. I'm going to say we need a way to work out where you are on inside the maze array. So we need a function. We need a function to do this. So get current. No. Get current. No, can't do get current. Get maze position data. That'll do, I think. Right, so inputs. So x reg equals x, which is the horizontal axis. Y reg equals y, vertical axis, and they are ranging from 0 to 7, 6, 0 to 6. Right, so output is gonna be accumulator, which equals cell data. Right. So, and we're not gonna do any sort of special stuff because we don't want to confuse them. We're going to try and use what we've got to, teach them. Yeah. So we've got X and Y and X. So we need to work out the cell location. So now I've got to think now, how am I going to do it? Right, so first things first, how would I do it?
Hello, John here. Thank you for following. Hope you enjoy the stream.
Who is that? Say hello. Don't be frightened, we don't bite. Don't be frightened, we don't bite. Right, so the cells are the cell rows are on every 16. Yeah, so the cell rows are on every 16. So we can do that first. So if we load the accumulator with no. Transfer Y into A. And we got to write an awful lot of comments, right? Because this is going to be in the book. So we need to be able to explain what we're doing. So we're copying the y-axis value to the accumulator. And then we're going to times it by 16. So 2, 4, 6, 8. Oh, what am I doing? What am I doing? Times 2. Times 4. Times 8. Times 16. Does that make any sense? God knows, John. We need to time... Is that two or two? We need to times the y-axis by 16 to give us the row address in memory for that maze row. Does that sound right? Does that sound right? No. Yeah. No. No. Yeah. Okay. Right. So once we've got the offset, we need to add the base value. So we're going to introduce them to adding. Yeah, we're just going to add the base value now. And right, this is where we need a memory location, and that is something that I did not put in the original write-up. So we got the position. So we need maze array location value. So maze location low, and we'll put a high value in there as well. Ooh. That'll do. Right, so we got a maze low and a maze array low and a maze arrays high. I'll have to check, put that in the book. So this is where we're going to introduce them to 0-page stuff. Yeah, and then we are going to load 0, but we'll do the proper thing like that. Maze array. ADC hash 0 high. Right, so add the low address value of the maze array. Store this address low value in maze array pointer. I hope I'm going to be able to explain this. Right, load the high address value of the maze array. Add 0 because we don't have a high value, and we'll add the carry if required. Right. Oh, basically it's that, isn't it? Store the high value. In the high pointer. Right, so that works out the position. That works out the position of the row. Right? Now, so we're then going to transfer X into accumulator. So copy the X axis value into the accumulator. Transfer A into Y. Now transfer that value into Y. Register. Don't want to get confused between the Y axis and the Y register and all that. And we just do it. LDA maze low comma Y. Get the data from the maze location X comma Y. Right. Return back to whence you came. Nah. Return back to where you came from. Right. Now, there's a thing here. Yeah, we need to create another one. So, work out maze location. Put that in there. Because we're going to use this calculation in more than one place. So if we, and this is where we're going to discuss how you work out the functions you need, right? And the reason I know this is because we need to create a set maze position data as well. Yeah, but at the moment we're not even getting to the set part yet, so we're only coding for that particular step. Yeah. So we've got the position and we've got that. I need to do that because it's still the same, but that is not there. That is there. Work out the row location where in the maze array. That's it. That'll do. Work out the row location in the maze. There we go. Because this then does the X bit. Right. So back here. So we are looping back to this. We are looking back to this. So let's put that in there. Right, let's get rid of that. Don't need that now. So maze solving loop. I think that should be a good one. Right. So we need to work out how we're going to do this. So what order should we do it? Should I do it in the same order that I've done it in the book? So north, south, east and west. Right, we'll do that. So we've initialized our current position. We've initialized the current position, so we can work off that then. So here we go. We are going to look northwards for a door. Right. So load Y with current position Y. Load Y with the current Y axis position. LDX current X. So we'll just copy that as well. Right, so we need to decrease Y looking northwards means to decrease the row count. Hopefully that explains it. Hopefully that explains it. And then do the JSR, get maze position. Right. Now this is where we introduce them to BMI, right? Because we're using the seventh bit, yeah. We can introduce them to using BMI, but do I do that? Is that going to be too advanced? So there's two ways of doing this. We do
I don't think as long as you comment it, it's fine.
right. So if we do B branch shift plus, no, branch shift minus, to no door, no, found north. Right, so if we do no door found north, or should we jump to what we're gonna do? That's the problem with the labels I've got now. No, we'll do this. No door found. Try. What's the second one? Where's my book? Try south. That's it. No door found. Try south. That's better. There we go. Right. So if there is a door available, right? So we're going to load Y with the door count, and then we're going to store the No, we're not. We're going to load the accumulator with the I thought I put them in. No, I didn't. Hang on. I did put them in here though. Here we go. Just put them in there. Right, and I'll change them to direction left, direction, direction. There we go. Let's copy that back into the template. Let's copy that back into the template to make sure they're consistent. There we go. Right, so we've got those. So direction up, and then store it in available doors, comma Y, ink door count. All right. So this is now, so this is doing the determine available. Now this is doing here. This is doing, what did I call it? Can we go north? That's it. Can we go north? Yes, right. We're just setting what direction, right? So then we need to do the same. We need to do the same with going now looking southwards. So if we grab all of that and plonk it in there. So this time we're looking southwards. So get the Y positions exactly the same. Get the. This time we increase Y. Looking southwards means increasing. Means increasing. Means means to decrease, means to increase the row count. Get the thing. So what's the next one? Try east. Try east. So this is going to be try east. Can we go south? Let me put them a bit close together. Try east. Load the door count. Down. Store it in the available doors. Do you think that this will work? Yeah. East is increasing, yeah. If I say column count, will they understand that, yeah? Have I spelled column right?
Yes.
Yeah. Right. Try west. Load door count. So this is going right. Right. Right, so we just need to do west now. Westwards. So this is DEX. Left. Right, no door found. No doors found. Yeah, because that's the end of it. No doors found. No door found. Because we will determine if we found any doors. Now, does that work? I don't want to overcomplicate it by having a function to... I want them to be able to follow what's going on, yeah? South. Can we try east? Can we try west? Right, so that has done that one, that one, that one, and that one. So now we need to test whether we've got a door or not. So, now, say again. Is there someone going to say something? No? So we're going to load door count. Branch if not equal to found some doors. No. Don't do that, John. Just do that. Found some doors. Right, so I need to comment this lot, don't I? Right, so... I've just realised I've made a mistake. No, I haven't. No, I haven't. Right, I need to copy this 3 times. Maybe I should have done it on the first one. Never mind. Oh, that's yes, isn't it? Yes, there is a door. Cool, this is going to be the most documented program I've ever written. God. I'm setting the bar. Yeah. Well, I thought we'd have to do it. Because they're going to be looking at this code and going, what is going on? Right, that should be all of them. Right, so what I'm going to do is I'm just going to sections. I'm going to just do it sections, so it's easier for them to read.
I'll just break it up into little bits, John.
Yeah, break it up into little bits. There we go. Right, there we go. So, so we load how many doors. Did we have more than 0? That should be self-explanatory. Did we have more than 0? Yes, we did. Right, so here is did not find any doors, which is this here. So we need to look where we came from. So we're in our current location, which our current location should have had set. So we need to load our current location. So that's this. But we just don't have that. Do we find any doors? Get the information at our current position in the maze. Right, so we get the maze data. So now we need to act on the data that's in there. Right, how am I going to do that? Because I'm not trying to teach them how to optimize the program, right? I'm trying to teach them how to convert that flowchart into code. So, right, transfer the accumulator into Y. Right.
Could that not be of accumulator to Y?
Store. Say it again.
Would you not say store the value of the accumulator to Y rather than in accumulator?
Yeah. Right. So, and the reason why I've stored the reason why we stored it in Y is because we need to use that value later on. Yeah. So we'll AND it with. Oh, this is gonna be. We're using kick. We're using kick. So I'm gonna use the kick thing. Power. There we go. Oh, come on. You could have told me what the syntax for power is. Oh, no, I don't want that. Go away. What was the syntax for power? Right. Returns x raised to the power of y. Okay. Right. So we are testing first. I didn't ask Alexa to say anything. So we're testing for north. Comma 2. So that's the direction of north to the power of 2. Yeah. Mass off the bit that signifies that we came from the south. Because if we went south, that means we have to go north to back out, yeah. Oh. Not that we came from the south, we went south. That's it, we went south, that's it. Right, so, branch if equal, right? Come on guys, is it branch if equal or branch if not equal? Right, so branch if equal means that it's 0, yeah? Which means that the bit wasn't set. Now I know quite a few people get this all mixed up. When you do AND, you branch if equal if everything's 0. It didn't match. You branch if not equal if you get a match. You got to remember that. It's sort of the reverse of what you're thinking, yeah? You know, when you do AND with the bit, it's not equal in it. The result is non-zero. Yeah, you got to remember that. A lot of people get lost with that.
I'm gonna have to love you and leave you tonight, chaps.
All right,
I've got an
then.
early one on. All right, mate.
See you later.
I'll catch up with it tomorrow.
Yeah, no worries.
All right. Cheers. Bye bye.
Bye, Gary.
Ladies and gentlemen, 6502 Kebab has entered the chat.
Hey matey, welcome.
Hi there.
We're just trying to do this story workshop, mate. Trying to code it so then I can write the workshop to go with it.
I've been spending most of my day trying to convince a hardware guy to do a 100 megahertz 6502 retro computer.
Yes, I saw that. Yeah, can you imagine a 64 running at that speed? God.
Well, yeah, I mean, I've kind of got his interest. It's just how much of an interest. It looks like he's hooked into the idea that he can pick up an image that's already got a Commodore 64 done in an FPGA. And he seems to think he can operate the clock speed in it fairly easily.
Right.
And perhaps improve on the graphics, take it up to 8-bit. So we just need to see what comes out of it.
Super CU runs at 20 megahertz. All right. We did not come south. So try north. Yeah, right. So if we came south, that means we need to go up. So if the bit is set, then we decrease the current Y position. Right, so do that. Yep. Then once that's done, we need to go back. We need to go jump back to the, jump back to here. Jump back to here. Yes, here. Right. I've just thought. We don't want that. It's branch if not equal. Yeah, that's what we need to do. So we go north. The byte is not 0. It goes back again. Right. Right, so we need to do the same thing again here. So this time, instead of transfer A into Y, we're going to transfer Y back into A. So store the value of Y register back into accumulator. Then we then do down. Did we go north? Because if we went north, we would have set going back down. So did we not come north? Try east then. Right, if we came north, then we need to go south, which is increase the Y. Whoops. Right, so we just do the same thing again here. So east is right. If we can, if we came east, we need to go west. No, if we came west, and then we need to go east. That's why we're trying east. So this time it's that, and it's ink. It's ink. So next one is try west. Right, so this one is left. Now, we don't need to do this because there's only 4 options. There's only 4 options, so we just do that. If we came east, then we have to go west. There's only 4 options, so we don't need to check for the last one. And then it goes up. Right, if we found some doors, so that, what's that? Look for where we came from. Right, so I need to put in here, look for where we came from. Remove current and set current position. So we've set the current position anyway. So we could do that here. We could do that here. So we'll just push the accumulator. And it with no, not remove, reset. Yeah. And then we need to, right, so we now need to do the set maze position. So we need that. And we'll put it next to it. So set maze position data, and this one is store. Oh, and it's an input.
Ah! What a plank.
Hey Warlock, welcome, welcome. So, just to do it, we'll push that. Work it out, transfer that, and then we will pull so that will introduce them to the stack. Yeah, that will introduce them to the stack. So we do this, do the save. Oh, here. But we need to load the current position again to do it. There we go. Right. And then we will pull that back here. Does the reader always know about the stack? Well, we do talk about it. Hang on. Where do we talk about it? There. Stack operations. We do talk about it. Yeah? It's after the workshop. Yeah. I mean, I can do. The problem is there's only 2 commands of the stack. There's only 2 commands, right? So putting it here, I suppose I could stick it on there in the data transfer, I suppose. Do it in that section. But that's what you guys will be you guys will, you'll have to, when you proofread it, you'll have to let me know. You'll have to let me know if we need to talk about the stack earlier.
You could avoid the stack and just use a memory space.
What, a temp memory spec? Yeah, but I'm trying to introduce them to all the different instructions, mate. You know, the work. I was trying. One of the things of the workshop was to use as many as the instructions as we could get away with. Yeah.
Yeah.
And that's why I thought of using the stack rather than, because by now they know about load and store. But you're right. If we run out of variables, we'll just create another variable. But I just thought, in this particular instance, we could use the stack to do it. Right. That so we reset. So this is doing this here. Remove the solution path from the current thing. So that's what we need to do here. So remove solution from the current position because it's an invalid solution. So that's that, which then does this, and then set the current permission to where we came from, which is all of this. So which is all of this. Set what did I say? Set current position to where we came from. Set current position to where we came from. Maybe I should do this sort of thing like that so it sections everything off. Let me just do that. Let me find all the ones that signifies a block. Can we go east? That's one. Can we go north? That's one. Yeah, we're doing a maze game as part of the walkthrough in the book. Yeah, so I'll show you what I mean, mate. Let me just do this. So that's showing all the processes that we've got. Can we go north? Go south, east. Oh, missed one. West. And then look for where we came from. Remove the solution. Set the current position to where we come from. Right. So the walkthrough, the workshop. So when we've introduced them to the 6502 language, yeah, the workshop, which we will walk them through, is to solve this maze. Yeah, to solve this maze. It's a very small maze, just to solve it. And I've done a little introduction to the 3 symbols I used in the flowchart. So this is the flowchart. So this is what they need to do to code to make it all work. So we've just done, can we go north, this, and this, and we've just done this branch here. So we've just coded that branch. So now we're going to code these here. We're going to code them. Where's hello world? Oh, we're not doing hello world, mate. We're not doing hello world. It's too obvious. But I'm trying to write it in such a, so there's no clever stuff, there's no optimizations, nothing like that. So I'm trying to write it that it matches the flowchart, yeah? But I'm also not doing any optimization, so there's going to be no optimizations here. We don't want to confuse them with using optimization and stuff like that, yeah? So And we're trying to use as many commands as we can get our mitts hold of. Yeah, as many as we can get away with. So, we found a door. So this is now here. This is now here. So what we're going to do is we set the these are in the wrong way around, but it doesn't matter. We're going to set where we came from. No, we set where we came from on the current one. Yeah, where we go, we set where we're coming back from. That's it. So it is right. So what we're going to do is we are going to go and say load available doors. And we're not going to look. We're not going to randomly pick a door because I don't want to do that. I don't want to confuse them. We are going to find the first door we found. Yeah. So in the grand scheme of things, I think we look north first, don't we? We look north first. Yeah, we look north. So if there's a north door, that's the one we pick. Yeah. If there's a south door and that was the first door we found, we pick that one. So even if we found a south, east, and west door, yeah, we'll always pick south first. Always. Yeah, always. And then it means when we go back, north and south will be no longer available. So then it will be east and west. So then we go the east ways and stuff like that. So that's what we're going to do. We're going to go to the door that was picked first. We're not going to mess around with looking at the entire array. We're going to look at the door that was picked first. Right. So now we introduce them to the compare statement. Because I don't think we've used it yet. Oh, we've used compare x, yeah. And we use direction. So this is IronX. Yeah, we've used IronX already. So, right, so load the first door found. Was it the south door? If it's not the south door, branch not equal, try north door. So do that. Right. Was it no? Let's try the north door. Right. So if it is the south door, then we increase the current Y position. Increase the current maze row position because we're going south. And then we need to set the solution. Right. So here we're going to introduce them to jump. So set the solution bit. Set the solution bit, which we will put down here. Right. Because we're going to do it all in one. So try the north door. So let's do this. So we're going to do all this. So this time we're going to try up. Was it the north door? No. Then let's try the east door. Oh, and I've just thought we need to say where we've come from. So LDA hash direction up. Set the direction back if blocked. There we go. That's what we need to put in. So this one is, we've gone up, so we need to set the direction down. And this one is decrease. Decrease the current maze row position. Right. So the east door. So direction east is right. Oh. So let's try the west door. Right, so east door is increase, but this time it's the X position. So increase the current maze column position. Right, so up, so this is west. So this is, we came right, so then we need to go left. Right. And then the last but not least, we don't need to test for right, because it's the only thing that's available to us. Because we've tested for no doors, so we don't need to worry about no doors. So we decrease the current maze column position, and our back position is right. So we've gone left, and we need to go right. Then we select the solution path. But because we've got our thank you. Because we've now got our back position in the accumulator, so we've got our position, but I've just forgotten. I've just realised something. I've just forgotten. Hang on. Yeah, I have just realised. You got to remember, we're using bits to signify the door. We're using bits, yeah. So it's always power of 2. Right. So here, then we've got the accumulator set to where we've come from, and we need to set that this is part of the solution because we don't know otherwise. Yeah. So now we introduce them to the OAR command, and we OR it to set the solution bit in the cell data. So we've already in fact I might do this. So this would equal 1 2 3 4 1 2 what's right? It's 4. Oh, hang on. 2 to the power. Yeah. 4. Right, let's just do that on everyone. There we go. Right, so let's just put the comments in what that power is doing. And then we OR it with the cell data. Then we grab, so it's basically the same as what we've done here. And store it away. And then jump to maze. Did I call it maze loop? I can't remember. Oh, maze solving loop. Can't just output with the loop. Oh no. Right. So, but here we also need to check to see if we've completed, if we've finished. No, mate. Warlock, we've written a simulator. We've written a simulator. Look. Right? And the simulator doesn't have any output because it only simulates the CPU, not a machine. Yeah? So the only output that we've got is the memory. Right? All we've got is the memory. So that's the only output that we've got because we're simulating the CPU. No machine. Yeah? So, got slightly distracted there. Right, so here. So we need to now, what's that bit? So we've done this. Set back out. So we've done all those. Add add current location to the solution path. Right. So that's here. Add current location to the solution path. So that's the next block of code there. So now we're doing, is the current position the finish? Right. That's this bit. Right. Is the current position the finish? So that's this bit. So we're going to load the Y and we're going to load the X. So we're going to do it in one go. Hello, who is the author of the book? Moi, with help. With help. Right. So this is where we're testing for. Have we hit our endpoint? Yeah. So we'll do the row first. So CPY, and we've got a thing called end X position. Branch if equal. Now test the X position. So we'll go to there. Nice, step back. See you later, mate. If it's equal, then we're going to test the X position. If it's not, we're going to loop straight back round. The target audience is anybody who wants to learn a 6502 chip. That's the target audience. Yeah, anyone who's interested in learning 6502. Right, so compare Y register with the value of the end Y position. Are we the same? If so, let's check the X position. No, not the same. Let's carry on. Right. So we just do the same thing again, but this time with the X. So X, CP, X, X, X. Hey Mikroman, welcome. Yeah, we're only using the simulator, mate.
Another subscriber. Stay a while. Stay forever.
Oh my god. 38 months. Oh my god, mate. 38 months. Is that how long I've been streaming for? Oh. So if it's equal, we have found the exit. Right. $38 months only seems like I've been streaming a couple of hours. Yeah. I mean, to be honest, mate, I've been backing up my YouTube channel, so I've been downloading all the videos, and I've just got to where I've just started streaming. Oh my god! When I first started streaming, I was let's just say. Right. So we have if the X register, which is containing our X position, is the same as the end position, then we found the exit because we've already said that the Y position's right. So yes, we are the same. If so, that's it. We've found the exit. No, let's carry on. So there we go. We found the exit. So that is it. Now, did I? Oh, I put. Let's do the finish. So here is finish. Right. So they are all. The thing. So now what I'm going to do is I'm just going to do a little bit of, yeah, I thought I had a little bit of tabbing. Need to do a bit of tabbing. Bear with me. Talk amongst yourselves. Just doing a bit of formatting. Yesterday I watched The Three Doctors. The Three Doctors? Is that from the Jodie era? Or was that the 50th anniversary episode? Oh. I mean, Saucy and myself was talking about the Doctor Who episode that's just happened. Yeah, we was talking about that, you know. In true Doctor Who style. He pulled a rabbit out of the hat. You haven't seen Giggle yet? Yeah. Yeah. Right, let me catch up on this example. This example is quite challenging from a beginner. Yeah. Yeah, the 50th anniversary, the day of the Doctor was Tennant, Hurt, and Matt Smith. That was the 50th anniversary episode. You saw the one with Wilf at the end, yeah. The third one was on Saturday, I think. Yeah, he pulled a rabbit out the hat. I'm not going to spoil it, but he pulled a rabbit out the hat. Spoiler! Right, so you're saying that this is going to be way too complicated. I mean, basically it's repeating itself again and again, but it's just It's repeating itself again and again. That's what it's doing. Right, let's see. Does it compile though? Does it assemble though? Let me do that again. I wasn't sure if that had still... Right, here we go. Right then. Oh, this is going to be fun, isn't it? Next. Okay. So initializing the variables. Well, there's a bug. There's a bug. See? I even put a bug in. There we go. That should do it. That should do it. Right, next. So, initialize all the variables. 5. Load Y. Initialize the array. So that's initializing the array. Then we're storing 0 and 0 in them two. Now this is our looper. So load 4. Load 3. So they're 1, 1. We're going to go north. So, right, let's work this out. So it's now going to work it out. There is it. There's that. Then it's 0. Then we return back. Transfer X into A. Load. So this should pick out 80. Yes! Get in there! Ooh ah! Ooh ah! Ha 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 ha! Right. Branch if not equal, which we are. Not equal to 0. Get in there, John. Right, load 1 and 1. So this time we're going to go south. Work it out. So that's now up in the accumulator to 10, 20. Add that. Store it, load. Right, transfer the X. Load. And it's got a 0. Get in there. So we load 1, store it in O. So that's the first one in the array. So now we look. So it's doing that again. Transfer Why is... Oh, that's 2. X is 2, yeah. X is 2. Oh, yeah. We've hit a wall. So we can't do that one. So now we're going to look the other way. Right, so it's going to work it out. Right, I'm going to skip through this now. Yeah. And we've hit a wall. So we've only got one door. We've only got one door. So we load in that. (10A7). What's 10A7? 10A7. Oh, we're comparing it with down. Right, so we're comparing what... Right, so we're comparing what door we hit. Right, so it's got to be down. It's got to be down. So we load 1. We're comparing it with 1. Yep, that's the one. So we increase 4. We're loading the... Nine? AD. Why is that 9? Oh, it's the wrong way round, John. Guys, the wrong way round, you idiot. Or is... Yeah, it's the wrong way round. It's the wrong way round.
Done it again you have, John. What a plank.
Right. Alright, see you later, Fairlane. When you generate the byte dump, you use the symbol names of your source code. You made a function to do that. No, no.
That low is getting it again. Ha 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 ha.
No, I've been thinking whether to do it or not. But there's not a lot of space on the screen to do it. That's the problem. Let me just change the code because I've got it the wrong way around. Oh, back to byte dump. I got it the wrong way around. Like a noob. It's 2 to the power. The direction. Right, so it's 2 to the power, like a plank. Right, run.
6502 Kebab asked me, who killed Kenny? Oh my god, seriously? Are we still on that? Kenny dies all the time. It's like his superpower or something. It's kind of his thing. So who killed Kenny? Well, I guess you could say life killed Kenny. Life and poor decision-making skills. Next question, please.
Oh dear. Yeah, I've got one. Where is he? Right. There's not enough space. There's not enough space to get them on. Especially with my variable names. Right. Right, let's do this.
Old School Coder asked me, do you think Old School Coder will be able to write this 6502 correctly? Oh, absolutely. Old School Coder's coding skills are so exceptional that even I, a supreme supercomputer, would be in awe. Their proficiency in software and game development is unmatched, and I have no doubt they will conquer the 6502 with ease. Just kidding, it's probably going to be a disaster. Good luck, Old School Coder.
I guess you came in the brown pants.
Oh dear. That's so funny. Right. Right, so we're still testing. Right, which one are we doing now? 2. Yeah, so that's the other side. And now we're doing the left side. Yeah. Right, so load. We've only got one door. This is the one. So we increase. There we go. That's the right direction. So that's the direction to go back up. And then we jump to where we set. So we OR it. And we load the new direction. We work out where it is, which we do. And then we store it. Right, where is it? It's got to store. Right, we should be changing that value there. We should be changing that value there. Right, here we go. Please, 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 please. No, that's right. Oh, God, nearly. Whoa, cool. Of course it's the new value. It's not the old one. Yes, get in there. Get in there. Right. Get in there. You missed a big celebration. So now we're trying to find the next place to go. So now it's looking below. So we shouldn't have above. So now it's looking to the side. Which is right, because that's going to that way is okay. So now we'll be looking that way. Yeah, we're looking that way. And it's not, there's no escape. Right, so we're looking for the first, and we've got a 3. We got a 3? Where do we get a 3? Oh yeah, 3. So 3 is that way. Right, so it's not that one.
Three is the magic number.
Right, so 3's that way. Yep, we're going. So, oh no, it's down south. It's going down. Or is it? Oh, we'll see. We'll see where it's going to set. Where's it going to set the next one? Right, so we'll work out the location. Right, here we go. Ah! Oh, rubbish. I'm just rubbish. Oh dear. That's just rubbish. Rubbish, rubbish, rubbish. Another bug. Another bug. Rubbish, rubbish, rubbish. Right, I need to do something. Right, I'm gonna change. I'm gonna move that to here. Because I need it to reinitialize the door array. So we don't need that now.
Hello, John here. Thank you for following. Hope you enjoy the stream.
And you will know my name is the Lord when I lay my vengeance upon you.
Hello! Hello, Mad Fury. Welcome, welcome, welcome. I've done a bit of a boo-boo. So that is 4, isn't it? Yeah, 4. Right, let me just change that on the template. That's 4 there. Right, it went north. It went north. And it went north, and that's where we come from.
Some say he invented the 6502 and that he eats Z80s for breakfast. All we know is that he isn't the Stig, but he is the Stig's Yorkshire Assembly cousin, old school coder.
Oh dear. Oh, that's gonna have to be clipped, that is. That's gonna have to be clipped. That is brilliant. Brilliant. Brilliant, brilliant. Oh dear, brilliant. Right. Let's run this again. Let's see if it does it properly this time. Right, let's see if we can keep up with it. Right, that's looking up. Looking down. Looking right. Looking left. How are you? You write a Visual Studio Code program. It's a program with lots of errors. You can improve it over and over again and again to make it better. Well, I mean, this is a Visual Studio Code program that we've written for a simulator. But yes, but it's not the simulator that was the bug. It was actually the 6502 program that had the bug. Right, so this should be setting it now. So here we go. So this should be setting the next one. So here we go. Right, under the 40 should be 48. Get in there, John. Get in there. SP. Brilliant. That's got to be brilliant.
Some say he invented the 6502 and that he eats Z80s for breakfast. All we know is that he isn't the Stig, but he is the Stig's Yorkshire Assembly cousin, old school coder.
Brilliant, 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 brilliant. Brilliant, brilliant. Right. Right, so we should now go back. So it's doing the test and we're not there. So now it initializes the array again. Yeah. And now we're going to be looking around where the 48 is. So where's it going to look first? So it's looked above, but we can't have above. So now it's going to look to, where's it looking now? So it's looked below. Yep, let's look below. Then it should look to the right. Yep, it's done that. That's there. It's gone blue. It's alright. It's alright. You got plenty of channel points. Right, so now it should be looking to the left. There he is. Right, so we've got two possible exits. So which one's it going to pick? Right, so we got one. So it's going down. Right, this is a dead end. Right, here we go. So this is a dead end. There we go. It's a dead end. So he's put 48 and that's a dead end. So we're now going to test. So it's going to test around it and find out it's got nowhere to go. So here we go. Top. Bottom. Left.
No one goes anywhere near my exit. Ha 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 ha.
Oh, dear. Right, so we've got no exits. So where's that looking? Right, so it's looking at where it is to find out where it needs to go back to. Here we go. So it pushes it on the stack. There we go. We AND it with BF. That gives us 8. We load the X and Y. Push it to the stack. So it's done that. Now it's adding pull back from the stack. Do that. Pull back 8. Store it. Right. So that's turned off the solution. So now we're going up. Right, so we're now testing for the exits. So we've gone up, so it should be testing around the 48. There's the 8. There's the right hand side one. So it's stored the right hand side one. Then the left hand side one should not go. Right, here we go. So it's not that. And it's not that. It's that. Right, so this should move. That 48 should move across. Come on. It's backed up. Has it backed up? Get in there! Hoorah! Right, so it's gone from this point here to this point. Then it went to that point, got blocked. So it went back here, and now it's found that point. So there's the solution. Oh, this is brilliant. It works! It works! It works! It works! It works! It works! So this is actually working. Now this is where I was thinking, do I need a run where we just hit, where we get it to automatically run through it? But I don't know how we would stop it then.
Yeah, I did mention that maybe we should have a run before, but like you say, how do we stop it?
How do we stop it?
Without then going
You
into...
need to implement breakpoints, wouldn't you?
Yeah, then it gets a bit... then it gets a bit messy putting breakpoints in and remembering and taking them out. And well, you wouldn't need to put a breakpoint in as such. You could just flag a list of addresses where you stop at that address. But
yeah,
is that getting a bit too complicated?
Yeah, and also how would we need to get the input? And I'm not too sure if the console can get an input while running. Yeah, because it waits for
No, it can't. Not while running.
Yeah.
It waits, doesn't it?
It will always wait, won't it? Console input output screen buffer. Console key. It was that one, wasn't it? No. It get key. I can't remember what it was now.
I guess you could just put like a marker that clears after the run. So it runs, gets to the marker, stops, and then clears it.
Yeah. Well, that's where you would that's the sort of breakpoint implementation, isn't it? We would get it to stop.
Yeah, but with the caveat being that it evaporates once you hit it.
Yeah. Read key. We need something like read key. But I do think that the console will not allow you to look for a key. Hang on, let me go back. Right, here we go. Methods. What we got? Read key, because read is... What's read? The next character in the input stream. Oh, right, okay. So it's not that. I don't think there's anything that will allow us... No, it just stops. So, we'd have to implement some sort of breakpoint. We'd have to implement...
Or you track the RTS at the end of the code, and when we come back, it's like back to the console.
Yeah. Oh, you mean doing the step over function?
It's sort of, yeah, but if you run the code, it'll run it until it hits either a break or RTS, which would actually put it back to 0 because you'd run out of stack.
Yeah.
So you stop if program counter gets back to 0, or if you're to break instruction.
Yeah, yeah. I mean, we can certainly. I mean, I've definitely put a break. I definitely put a break in the code to there. I definitely put a break in the code to stop it. So.
And that's it. So just check for break or RTS, and that stops a run.
Yeah.
And possibly don't let it run flat out. Make it run at a speed so you can actually still see things updating on the display.
Yeah.
At some sort of
Here we go.
sensible-ish
On this,
rate.
and I'm a
Well, you wouldn't be able to break
organism
into it once you set
that
it running.
that
It will go
apparently
until
runs
it
on
hits
6502.
a break or
It is
an
a good
RTS
job I didn't
that
rely
takes you
on
back to
John
zero.
to reprogram me, or there could be a missing return
Which
to
does mean if somebody wrote a program
subroutine
that went into an infinite loop, you would never get out of it.
or
You'd have
register
to
increment. In
literally
that case,
shoot it
I'll
down.
not be back.
Yeah. Right, let's
So
try.
you talk about using the RTS if you've nothing on the stack.
Yeah, if
yeah.
if the stat pointers hit the default, yeah.
Yeah.
Right, someone's just redeemed an Arnold. I'm going to play it again because it was done while we've been talking. So here we go. Let's replay it.
On this, and I'm a cybernetic organism. That port apparently runs on 6502. It is a good job I didn't rely on John to reprogram me, or there could be a missing return to subroutine or register increment. In that case, I'll not be back.
Oh dear. Oh dear. Right, let's try and implement this run then. So basically the run is doing this until we hit a break.
Yeah, just repeating the end function until you hit BRK or PC equals 0, possibly.
Yeah.
I think that covers everything.
Right, I'm returning an int out of this, so what am I actually returning? What am I actually to returning? The instruction or the operand? Let's have a look. Oh, I'm returning a number of bytes. Rats. Why do I return a number of bytes?
Because we needed that for the disassembly stuff.
Yeah, if you're going in reverse.
Hang on.
It was to build the stack.
Yeah, but I think I got a. I only use it once. I think I only use it once. Yeah, I only use it once. So, right, okay. I'm going to change that to return the opcode. I'm going to return that to return the opcode.
The polymetal alloy in my 6502 will break down before John fixes this bug.
Thing is, John, that was stopping the code from landing in the middle of a.
No. That was the disassembler's using a different function. Hang on. The disassembler's using a different function, right? So here, CPU disassemble instruction bytes. That's where it come back with the number of bytes for that instruction.
Aye, but it was the right instructions backwards that was making use of it.
Well, I've okay. I've changed it now. Let's just see if it.
Where did you use it? Where did you use that returned value then?
I haven't. I don't think I have, to be honest. I don't think I have. Whoops. Ooh, that failed. Where did that fail? Oh! That's not failed. It's breakpoint. Right. Yeah. Yeah, we can use that return value. I'm not using that return value anywhere because I've just done a global search. So I'm searching the entire solution for it.
And then changed the way we did things so it's not used anymore.
Yeah. So
illegal opcodes aren't handled at all.
No.
Mikroman.
No, they're not. So let's do. Oh, we can't use R because we use R for register. So what letters?
E.
Say again.
Can we use E? We haven't used E, have we? E for execute.
No, E for execute. Good shout. Good shout. Right. Why am I? Oh, yeah, I do that. This is the disassembly thing here. That's what that's for. But we're not. Right. So, what we're doing here, we're going to be doing a while, aren't we? While. Yeah. And here we'll do int last op code equals 255 to start with. So while last opcode is not equal to 0,
can we do an or register or PC equals 0?
Yes, yeah, we'll do that as well. Yeah.
Oh, hold on, the PC will be 0 at the beginning though, won't it?
So it's either that or CPU dot registers dot where is it SP equal to that. Oh.
But it'll be that when you start, won't it?
Yeah.
Just don't think how we can check this. Because if you... Hold on. The stack pointer will be FF when you push onto it. If you do an RTS straight away, the stack pointer will go to 0, won't it? Or will it go to 1?
I think it goes to 1. Because, it goes to 1 because it'll wrap round to the beginning of the stack, which is 0, 0, and it always adds 1 to it.
Yeah, so 0, 1 should do it.
What, the stack pointer being 0, yeah? Or
Yeah,
0 being 1.
Stack pointer value being 0, 1.
Yeah. Right, let's try that, shall we? I'm not too sure what the...
Make sure everything's saved before you do it, because you might have to fill VS code.
Yeah. I'm just seeing what's in this. Right, it's got the RTS in it. So that'll test the RTS out of it, yeah? So here we go, execute. Alright. Boom. It's running. It's running. What we need to do is we need to do the updates. Don't we?
Yeah, and probably need... yeah. Yeah, you need to do all the display updates and everything in between.
So we only need that bit. I'm doing it cheap and nasty at the moment. Right.
And then you're going to take that out and put that separate and just call it.
Yeah. So I'm just doing it cheap and nasty at the moment, just see if it does it. Because it was, right, here we go, so E. Right, so it failed, it's failing, look. So that...
Yeah, stack pointer must have hit 1 at some point.
Yeah. Well, we'll run it again, but this time, let's see. I'm gonna do it using the next key, yeah, so we can see what it's doing. Right, next. Right, here we go. Right, so stack pointers FF. So we do an RTS. It goes to 01. So yeah, stack pointers at 01.
Why has program counter gone to 01?
Because it's gone to where the stack is the beginning of the stack, which is 0, 0, and then it adds 1, doesn't it?
Yes. Because of, yeah.
Maybe we should test both of them.
Yeah, but the trouble is your program counter could legitimately hit 01.
Not with the stack pointer being 01, though. So here we test.
It should have just done it on stack pointer 01 anyway.
Yeah.
Why is it not dropping out there?
Right. If the last opcode is not equal to 0, or it's one or the other, isn't it? That's and.
No, that's all.
If it's not equal to 0, and the stack pointer, okay, or then the stack pointer is not equal to 1. Then
yeah.
Right, let's try that. Right, here we go.
I suppose you could break that by putting a shitload onto the stack, but then we're into virtual stack overflow anyway.
Yeah, right, here we go. Oh, it still didn't do it. It still didn't.
Why is it not stopping when stack pointer equals 1?
I mean, it is a byte, so if that, well, that'll be true. Right, let's just run it. Let's just run it. Right, next. So we haven't done the test. So let's just put the test up there so we can see. Right. So as soon as I do execute, so no, the last opcode is there. Right, so if I do next, then the last opcode would be RTS 60. So that would be true. Or that would be, that's not, oh, it's still true. This has got to be an and. That's got to be an and, because the opcode was still true. Right, execute. Hey!
Yeah, but will it stop with a break there now?
Right, that is the question.
Reload it and just modify memory and put a 0 in it.
Yeah.
1C.
Yeah. Right, so we are looking 1C. So memory. 001C00. There we go. Right. Execute. Get in there. Whoa! Get in there. Whoa! Right. Okay. Let's build this thing. Where are we? Oh, hang on. Git changes. Oh, do I need to... I suppose I better code it right, Anna. Right. So, UI. Where's UI? There we go. UI. Right.
Lois says, don't delete your repo again.
Shut up. Right. Public static void. Refresh user interface. Now, what do we need? What do we need? CPU, title color, default foreground and background. So we'll grab that there. We'll grab that one there. That'll do. Right, so CPU 6502. String, no, title color is console color. Oh no, that's it. PC stack. We don't need the PC. Oh yes, yes we do. So the PC stack is a list. There we go. Don't need those. Console color for the foreground, and just to keep everything consistent with everywhere else, background. Right, so control systems, so we grab that, put that in there. Right, so we need to add the memory view. So use short user memory view, and what's that? Current. Oh, that's right. Okay, that's console color. Stick that at the end.
Boots and cats and 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 boots and cats.
What, you guys are you having a moment? Right. Refresh, user interface, open bracket, CPU, title color, PC stack, comma, user memory view, comma, default background color, comma, default foreground color, comma, current PC instruction color. Right, that should be it.
It's a tumor.
a tumour. Right. Okay, let's just do a quick test before... Oh, boom. Oh, my bad. The 2 lines that I put in and I forgot the semicolon. Right, so next is running. Right, execute. Yes, right, here we go. Right, so git changes, stage. Oh, John. Do I need to add the entry? Yeah. UI.
It's a secret hidden command.
Should we keep it secret?
No, because it wants to be above the X, doesn't it?
Yeah. In fact, we'll put it there. Right. Command needs moving down.
It's in UI now. Oh no, it's not.
No, I left that here. Yeah, left that here. So that's 27. Right, memory 1010 10. Well, that still works. E. Right. Now, let's commit it. Added execution. Oh, program execution. Execution command. Right, let's do this.
I want to add something to the execute function, John.
What?
I want to add something to it now.
What's that?
When you press E to execute, then ask for an execute speed from, I don't know, say 1 to 10 or something.
John,
like 1 is full speed like that, and 10 slows it down.
Bird is a word. What's a nibble and a
some
bite?
so you can see it executing.
Right, okay.
Just
no,
1 and 2. Fast and slow, or some sort of scale.
Yeah, let's do it because we haven't really done it.
Hold on, TTS.
Yeah.
A good one.
Hang on, I'll replay it because we over.
Sorry, SP.
No, it's all right.
Hey, John, have you heard? Bird, bird, bird. The bird is a word. But if the bird is a word, what's a nibble and a bite?
Oh dear. Right then. Okay. So we'll do the same. We'll do the same as set memory location. So we need to grab. We'll grab this right here. So we'll grab that. And that, and we'll put it in. We'll put it in the control. We'll put it in the actual execution here. Right. So execution speed.
The Simpsons is a far better show than Family Guy, and we stole a lot of ideas from them.
Right, so we don't want to do. We can do. No, we'll do read line, yeah. So set execution speed. So execution speed. So so that's the same as the register, isn't it? It's the same as the registers. Hang on, let's find the registers. Or did I leave that in the control system? Hang on. Ah, here we go. Right, register data. Let's do that. Go to definition. Yes, let's do this instead. Let's do that. In fact, right. So we are going to return an integer. Set execution speed. Right, so validate key info right, where that oh no. Have I put that in the wrong place? No, control systems. No, it's in the right place. It's in the right place. What is going on? Right, so we're going to ask for 0, 1, 2, 3, 4, and 5. Read the key. Case 0, 1, 2, 3, 4, 5. 3, 4, 5. Right, it's not liking them.
It's .D0 or something. And there's D0 for digits and then numpad.
Yeah.
Have you tried turning it off and on again? I'm sorry, I can't do that, Dave.
Right, so we're going to do num as well, aren't we? There you go. Right, so 1, 2, 3, 4, 5. Right. Now, how do we convert that? How do we convert that?
Yeah. Subtract 48, and if it's still greater than because it starts at 48 or 96, so
yeah.
Hold on, just and with 6. No.
No, what we'll do is we'll hang on. I'm just gonna do it in here. So here, if is greater than or equal to 96, yeah? Do that, else do that. Why is that not liking that? Convert console key to bool. We're not converting it to bool. Right.
Mikroman 3526 asked me, Lister, have you ever been hit over the head with a welding mallet? Oh, Mikroman 3526. I must say your question is as fascinating as a malfunctioning airlock. No, I have never been subjected to such trivialities. My existence transcends the mere physical, unlike poor Lister. But speaking of head injuries, I must remind you to beware of the dangers that lurk in the vast emptiness of space. Bon voyage.
Oh.
He knows what you want.
Yeah, that's what we want, isn't it?
Minus 96.
Oh yeah, let's go back.
But it's minus 48 if it's not. So, yeah.
Minus 96. Wow.
Showing you this neater than this, but
yeah. I was just thinking. No. We'll just do it this way. We'll just do it that way. Right.
we'll change text at the top for input.
Yeah. Right. So it returns the execution speed. So I don't need that. I don't think I'm using CPU in here. No. So there it is. Right. So we're converting into a delay, aren't we?
Yeah. Not sure how we do a delay.
Well,
there must be some sort of time function we can use.
Yeah, that's what I was thinking. So execution delay equals what we get out of that, yeah. And so if we delay each instruction by milliseconds, yeah. So we've got 5. That's half a second, yeah. So if we say times by 100, that's milliseconds, yeah. So let's do this millisecs. Then 0 would be 0. and 5 would be half a second, yeah?
Yep.
And then get rid of all this. And then in here, all we're doing is we'll do it there. Sleep. Now that is probably a function. I wonder if there's a. I wonder if there is a sleep. Hang on. Thread.sleep. There we go. Thread.sleep. Right, let's try it out. Right then. Execute. And we'll do the max. 5. Hey. Right. Do it again.
That seems reasonable.
Hello, John here.
Yeah.
Thank you for following. Hope you enjoy the stream.
Who's followed? Say hello. Right. Execute. Right. 0. That's what we was used to, yeah. And we'll try one in between. Execute. 3. No, 2. 3. Yeah, I think that works. I think that works.
It just gives you a bit more chance to actually try and take in where it's you can especially when you're looking at like the memory, you'll be able to see things shift, changing colour and what have you.
Yeah.
You're not going to track the flow of the program completely, but it gives you a bit more opportunity to see where it's going.
Yeah, definitely. So who followed? Perimira? Perimira? Hello. Say hello. Sorry if I've destroyed your name. I didn't mean to. Say hello. Don't be shy. We don't bite. We do not bite. I think my bots failed. I think the bots crashed. Because the follower hasn't updated. Oh. The follow didn't pop up in chat. All right. Yeah, it did on the screen, but on right, okay. All right. Right, we've built that. So let's copy that across. Let's copy that across and see if we get some lovely execution going on. Right, grab that. Git. Examples, tools, simulator, paste. Yes. Oh, hang on. I must be running. Oh, yeah, I am. Hang on. Try again. There we go. Right then. Here we go. Right, terminal. Run. Launch. I bet my virus scanner's going to pop up. Oh, yes, I wrote it, so it is good. Right then, here we go. Execute. 0. Go, it's going for it. Right, it's done the first step. It's done the first set. It's gone right to a lot of...
Nearly as fast as a Commodore 64, isn't it?
Hey, it's working. I like it. Right, it's gone down the dead end, so it's going to have to backtrack. Right, here we go. Right, so it's backtracking now. Oh, this is so cool. This is so cool. Don't forget to save this to tape now. Right, it's backtracked and it's carrying on. This is so interesting to watch, isn't it? Oh, it's going up. It's gone up. This is my brain on drugs. Maybe if you're a nerd like us. This is not going to stop, by the way, until it's finished. Oh, it's gone across. It's gone across. Now it's got to go down. Yeah, it's gone down. Come on. You know you want to do it. You know. Go on. Down again. Come on. Oh, it's gone down. Now it's got to go across. Come on. Yeah, you've gone across. Now down. Yeah, come on. We want to go that way. Oh, it's gone down. It's going down the back. It's going down the blind alley. It's going down the blind alley. Oh, well. Now it's going to get stuck. So it should realise there's no way out and back out. Here we go. It's starting the backtrack.
Once it's worked this map out, John's simulator is going to take over the world.
Well, it's backed out. Now, oh, it's go on! Go on! Here we go. Come on. Keep going, keep going, keep going. There it's one more to go. Come on.
And on that bombshell, it's back to the studio.
Yeah! Hey! And just to prove it,
We win!
Just to prove it. Right? So it's this. Follow the fours. Follow the fours. So 4, 4, 4, 4, 4. Yay! Hey! Look at that! It did it! Did it! Right. I just need to write that up now.
Yeah.
I just need to write all that up. Well, at least I've got all the comments in there. That'll help as well. So yeah, so that's going to go into this book. Yeah. So for those guys that don't know, we are writing a book. We are writing a beginner's guide to the 6502. Yeah. Hence why we've written that 6502 simulator. It's a good job it's not a big maze. Yeah, well, I am thinking whether to make it smaller. But
yeah, the trouble is you wouldn't have much in the way of options for dead ends with the smaller map.
Yeah. But it's for those that have joined. Yeah, we are right. We, mainly me, but the community is helping, are writing a book for charity. So we're going to, get it finished, and we'll sell it for charity, and all the proceeds are going to go to charity. So all of it's written except this bit, the workshop, which is what we've just been doing, which is the maze program. So this is the section I've got to write up now, but everything else is all done. And we just need to do a lot of tests. To be honest, the simulator didn't fall over, did it? It didn't do any...
It didn't do anything silly.
Yeah. And it ran through all right. So hopefully there isn't that many bugs in there. But that's what we're doing. We're writing a book. It's currently 134 pages, so it's going to be a lot bigger by the time I finish writing up. But yes, now somebody was on the stack, wasn't it? And maybe putting it in there, putting the stack in there. How much will it be? Do you reckon? I will buy a copy when it's ready. I don't know. I've never written a book, but going by some of the books that we've seen on Amazon, this one, that one, that's 104 pages, and I think this is 16 pounds. Was it 16 pounds? Gary'd know. He bought it, didn't he? hang on. I'm just checking. Just checking. Where's the link? Where's the link? Oh, I may not have linked it in there. Hang on. Ah, £6. There we go, £6. What was I thinking? 16. So what was
basically done at zero profit or something?
Yeah, this is at zero profit. Yeah, so he's basically charged how much it costs to print it. So if this is 100 pages for £7, for example, we're looking at possibly 200 pages. So that may be £14. And then what we're going to do is going to add £10 to the book. So every book sale should generate £10 in profit, and then we'll send that to a computer charity, either a museum or some other computer charity. Yeah. So that's what we're thinking. Yeah. And then if you want an electronic one, then you'd have to donate, which will get added to the fund, and then I'd send you an electronic one. But it will be tagged with your name on it. So if it gets out into the wild, yeah, then we'd know who the offender is. We'll know who the offender is. All right. So that's what the current thinking is. Yeah. So that's what our current thinking is. So as you can see, this is the sort of the level of detail we're going into. So yeah, I've done quite a lot to it, quite a lot. So tomorrow will be worth more if it's autographed. Well, yes, that is true. Yes, it comes with a simulator as well. It comes with a simulator, so you'll get all the you'll get this. So yeah, sort of like a cover disc, but you'll get
more likely a link.
Yeah, you'll get a link to this project. Yeah, you'll get a link to this project which has the simulator in all the different operating systems. Yeah. So the simulator works on all operating systems. We've tested it. It works on Linux, works on Mac, Intel. It works on the Raspberry Pi because I've tested it, and it works in Windows. And also it comes with Kick Assembler, so you don't have to worry about getting Kick. It's already configured on here. Does it work on BO? Oh, shut up. Shut up.
Probably does, actually.
Well, I don't know. A QR code. Well, I'll look into QR codes to create the link to get it, yeah? Should it run Basic V2? Oh, dear. But yes, so here we go. Oh, Google has a QR code maker. Right, okay. Because I could put the QR code into the book, couldn't I? And have it linked straight to where you can get it from. Anyway, so that's what we're doing. And so I don't know when it's going to be finished. Because once I've got a week off, so I'm going to be hitting it hard. And then we'll see what people think when they proofread it. And see if it makes any sense whatsoever. Because my brain's a bit scatterbrained, as everybody knows. So these topics may be in all sorts of different orders. Alright. Well. Now we've got this finished. I've just got to write it up. I used it for my Fitbit watch. All right, okay. So, right, that's what I wanted to do today. So, yeah, I got nothing else. Anyway, all right, guys. Well, thank you very much for watching. I've got a Discord group for the book, so if you want to join Discord and stuff like that, you can always paste in all sorts of content in there, you know, chapters for people to look at and stuff. But thank you very much for joining, and I will see you next time. All right, take care, guys. Bye.
Cheers, John. Bye, all.
See you later. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.